Hello and welcome to week 3 of C++ programming. In this lab 4, we are going to perform one of the practice programs from chapter 3. Number 7 in the Savage text asks you to develop a program that finds the temperature that is the same in both Celsius and Fahrenheit. We're going to make an adaptation to that. Instead of just simply finding that one value, what I would like to do is to create a menu-driven program that allows us to convert Fahrenheit to Celsius, Celsius to Fahrenheit, and then we're going to throw in a third one, meters per second to miles per hour, or actually the other way around, miles per hour to meters per second. Okay, so in this practice program, we will pick up one of the multi-branch decision structures. In order to create a menu-driven program, I want us to use the switch case. So we haven't used just a simple if-else statement yet, the simplest of the decision structures. Remember in last week's video, we talked about the 3 main control structures: sequence, decision, and repetition. And in our program last week, we got practice writing the repetition structure in the Babylonian program. We wrote, pardon my dog Gadget. So as I was saying, we are going to use the multi-branch decision structure, the switch case, to write this menu-driven program. So I'll start by opening Visual Studio, and we will be creating a new project, a new console app, and I'll call this conversions menu. Okay. All right, so in this program, as I already mentioned, we're going to create a menu-driven application that converts, makes those conversions for us. And so in the description, I'll say this menu-driven program will give the user the choice between performing a Fahrenheit to Celsius conversion, and then I'll just abbreviate C to F, and then MPH to meters per second. Okay, so with a menu-driven program, we will need a variable to store the user's selection, and we'll also need variables for Fahrenheit, Celsius, and then miles per hour. So I'll start by creating those variables. an integer for the choice. And I'm using a notation here. This is what's known as Hungarian notation. I got into it early in my development career, and I liked it because just by naming your variable, you could tell what kind of variable it is. That's really not necessary with these more advanced IDEs like Visual Studio. If you want to know what the data type is of a particular variable as you're programming, instead of having to look back to see where it was created, you can just hover over it and it tells you that it's an integer. But you might see this notation from time to time, Hungarian notation. What it is you put the data type in front. So for an integer, you put in. If it's a string, you put str. But like I said, that was back in the days when I was programming in Borland compiler, and you didn't have these advanced advanced IDEs like Visual Studio, or at least I wasn't using Visual Studio at the time. We need variable storage locations for degrees Fahrenheit, degrees Celsius, and then miles per hour. And I'll just use regular camel case there. Next, we're going to display the menu, and I'm going to go ahead and add my using namespace statement. That way I don't have to use this standard out in front of each one of these. Okay, and I'm going to have this say main menu. I'm just putting some tildes in there for visual effect. And these I do want to be separate cout statements. First choice, convert F to C. If you wanted to be more specific, you could say, you could write out the entire name, Fahrenheit or Celsius. Convert C to F. I'm putting inline characters here. Now that I'm thinking about it, you really wouldn't have to have these additional couts there. That's just extra typing. As long as you remove the semicolons from the end. As long as you don't end the statement, it carries over to the next line as though the compiler reads it like it's white space. MPH to meters per second. And if that inline character is confusing to you, you could always do this. You could chain onto the end of that, the end line, like that. Whatever you want to do. This is just more typing, so I usually use the end line character. And especially if I can keep from having to type as many of these, or as few of those as possible, because that not great with typing numbers as well as special characters. Those are always just a little bit slower because you don't type them as often. At least that's my experience. I'm going to read that choice in to the in choice storage location. And then we're going to start our multi-branch decision structure, and I'll go ahead and label it as such. Switch statement. Okay, so this is the multi-branch decision structure. With the switch, you pass in some value, and then you set up choices. You set up these cases, and when it finds a case that matches, it executes that case. So case 1, and it's trying to match this integer to that case. Now, you could also pass in a character and try to match this to a character. And if it was a character, then you would need the double quotes. So the case structure doesn't have to be numeric. In our case, it is. We're having them type 1, 2, 3, or 4. Actually, I forgot the 4th one here. Let's add that. I want 4 to be exit. And I'll use the inline character. Okay. Just some formatting. There we go. Back to the decision structure. Case 1, if the user chooses case 1, then I want to perform that calculation. And you do need the colon after your case number. So case 1, and that's converting Fahrenheit to Celsius. So that formula is going to be the reverse of what you see in the text on page 173. So that's going to be the Fahrenheit plus 32. Oh, actually, we need to prompt the user for those values as well, don't we? We haven't done that yet. So that will be first thing we do here. Enter degrees Fahrenheit. We're going to read that in to degrees F. Then we will output the conversion and do that multiplication all in one line. So I'm going to say, actually I want to display degrees F and I think we can actually display the degree symbol. It is a special character. I believe it is character 370 in the ASCII character set. We're going to give that a shot and see if that works out. So we'll say degrees F and display those is, or we could just say equals. I'm using double equals there. That's a programming equals. We'll get to that in future lessons. But that's just a string saying that these two are equal. And then we will display the result, which is going to be degrees Fahrenheit plus 32. And that needs to be surrounded in parentheses. That needs to happen first. Then you will multiply by 5, divide by 9, or multiply by 5/9. So asterisk, and then 5 over 9. And that also can either be displayed this way with parentheses around it, or you could multiply by 5, divide by 9, since in the rules of arithmetic state that PEMDAS, please excuse my dear Aunt Sally, parentheses, exponents, multiplication and division occur from left to right simultaneously. So in this case, you shouldn't need parentheses around it, but it never hurts to put it if you're ever in doubt. right, so that's case 1. Case 2 is converting Celsius to Fahrenheit. So we will prompt the user, enter degrees Celsius. And if this degree character ends up working, then we will, we could go back and convert that all over the place here. So enter degrees Celsius, CN degrees Celsius, read it in, then output the result. And I do want to display those again. Degrees Celsius equals and here we can use the formula as shown in the book, and that equation from the book is 9 times degrees Celsius divided by 5. They have parentheses around the top portion, but again, multiplication and division should happen from left to right in that order. Plus 32. All right. So notice I put a break statement here at the end of case 1. I did that while the video was paused, but this is a common mistake in switch cases. If you look at page 133 in your text, 132 in your text, it mentions forgetting a break statement is a common pitfall. Now, I have seen developers that use this to their advantage. Let's say you wanted several consecutive cases to all execute the same piece of code. Then you could omit the break statement and have case 1, 2, 3, and then finally have your code implementation inside case 3, then a break statement. So you can use that structure to your advantage, but typically when you're making a switch statement, you have a break after each case. Okay? So case 3. Enter enter miles per hour. Read that in. And display it. And say miles per hour is equal to so the conversion from miles per hour to meters per second, this is just an abbreviation, divide by 2.237. So this is an approximation. Miles per hour divided by, and should we type the number 2.237 in there? In programming, there is a thing called a magic number. Anytime you've got a hard-coded number in your application, it's referred to as a magic number, and they're generally frowned upon because if someone else comes along and sees the number, someone else coming along in the software development lifecycle, and they're maybe called upon to add a feature, and they're looking at your code and they see this number, they may not know what that number is or what it's being used for. In this case, you can kind of tell, but if you can be more descriptive, then you should, or more precise. So let's create a constant here, and that constant will be the conversion from miles per hour to meters per second. So we'll call it MPH conversion, or we could say MPH to meters per second. We could say MPS, maybe. Conversion factor. That's a really long variable name, but let's just stop it there. MPH to MPS. And we're going to set that equal to 2.237. And instead of divided by, really, it should be a multiplication problem. That's just typically the way it's done. Instead of using that 2.237, let's use the multiplier, which would be 0.44, the reciprocal of that value, 0.44704. And this is a double. Const double, miles per hour to meters per second. Usually conversion factors, you convert it to whatever the decimals that you need to multiply by. So I'm changing this up. MPH times, and then our constant, MPH to meters per second. And display the unit. Oops. Meters per second. Okay. The last case, case 4, is going to be just an exit. So really, we don't need to have anything there. So before we continue, though, there's a funky thing about switch cases. Switch cases, when it finds a case that matches, it will execute that case, and then it will continue and execute every single line of code it sees below it until it hits a break statement. So what we need to add is we need to add a break statement to every one of these cases so that it doesn't drop through to the next, doesn't continue executing code. Let's go ahead and run our program and see how it performs. Okay, here's our menu. Let's try all 3 of them. Number 1, enter degrees Fahrenheit. I'm going to choose one that we know what the conversion is. So 212 degrees Fahrenheit is boiling point of water. And look at the degree symbol. It worked out. That's pretty great. And it's equal to 0. And I forgot the degrees Celsius on the end there. So let's make that change here. So there's degrees Celsius. I want to put a space in front of that as well, all of them actually. And here, enter degrees F, if we wanted to change that to /370. That is how you display the degree symbol. I'm going to do the same thing here. And at the end of the Fahrenheit or Celsius to Fahrenheit conversion, let's place that degrees Fahrenheit. Okay. All right. Let's run our program again. So let's try Celsius to Fahrenheit this time. Enter degrees Celsius. Let's go with the freezing point of water, which is 0 degrees Celsius. That should be 32 degrees Fahrenheit, and it is. Great. Okay, let's try meters per second, and then we'll be done. So with meters per second or miles per hour to meters per second, let's pick a common engineering value. How about 70 miles per hour, since that is a common speed limit? Convert that to meters per second, and we get 31.2928. Okay, so that concludes this Lab 4. Email me if you have any problems. Don't forget the break statements in the case structure, and in the next lab, Lab 5, we are going to do number 6 right above this problem, Archimedes' principle, and in that project we will learn the regular decision structure. Okay, so good luck and know yourself.